Hi guys, this is going to be a video which is just going to introduce you to combustion equations and in particular how to balance them. Okay. Now combustion equation occurs generally when we have something that burns in oxygen, and we're going to be looking at it in terms of organic molecules that burn in oxygen. Now there's two types of combustion equations. When you have more than enough oxygen that you need, you'll undergo what we call complete combustion. Now complete combustion means that all the substance burns, okay, and it burns with enough oxygen to generally produce a blue flame, and the products of that are carbon dioxide and water vapor. Now, if you don't have enough oxygen, a really good indicator of that is that your flame will burn with an orangey glow to it, and there'll be a lot of soot or black smoke with it as well. That incomplete combustion is due to not enough oxygen present, which means we're not going to get everything, all of our carbon converted to carbon dioxide. All right, we're not going to get all of our hydrogen turning into water vapor. So instead what we get for incomplete combustion is CO2 and H2O, same as above, but because we don't have enough oxygen, we also get carbon monoxide, which is a poisonous gas. It's an asphyxiant, it stops oxygen being drawn into the body, and we have carbon, which is often called soot. That's a respiratory irritant, can cause cancer if it's breathed in. Okay, so incomplete combustion is quite dangerous. It also releases less energy, so it's very undesirable. So you always want to try and have anything burning with a nice blue flame. Now you can actually see this in the chemistry lab really simply if you just turn on a Bunsen burner, okay? If you turn on a Bunsen burner with the holes closed, you'll see you've got an orange flame, okay? That's incomplete combustion. But when you open the holes on that Bunsen burner, the flame will go blue because you're letting excess oxygen in through those holes. And that will allow your flame or your gas that's coming through to actually combust completely, so you get a much cleaner flame. It produces a lot more heat, which is very desirable. So I'm just going to show you how we balance or write combustion equations by just showing you a couple of examples. So the first one I'm going to show you is a very, very simple one, right, which is just methane, probably one of the most simple organic gases that we can burn. All right. So when we combust that, we react it with oxygen, and if we're undergoing complete combustion, we will get carbon dioxide and water. Okay. Now, really simple when you're balancing these. I always start with carbon atoms, then I do my hydrogens, and I always leave oxygen till last, okay? So the order I do them in is carbon, hydrogen, oxygen. So if you remember CHO, okay, CHO, that's the order which I do the balancing in, and it makes it much more simple, all right? So you're starting with one carbon here, we've got one carbon on this side, so that's fine. You've got 4 hydrogens here, so over on this side, we want to balance up with a 2 in front of the water. Now the reason we leave the oxygens till last is because in a complete combustion equation, you've got oxygen in 3 different places. You've got it here, you've got it here, and you've got it here. So it's much harder to balance up, all right, the hydrogens end if you start balancing with the oxygens, whereas your hydrogens are only in one spot on each side, so it makes it more simple. All right, so then you have a look over on this side. We've got 2 oxygens here, we've got another 2 here, so that gives us a total of 4 oxygens on this side. Got 2 oxygens here, which means that we're going to need to put a 2 out the front of this to balance up our combustion equation. And that's a balanced equation right there. Now one of the good things to know with combustion equations is you can actually use fractions to balance as well, which makes things a lot simpler. Okay, so I'm going to show you one where we have to use a fraction to balance it. So I'm going to go here to butane, which is C4H10, and we're going to do a complete combustion equation for this one. So again, we're going to combust it with oxygen, and we're going to get carbon dioxide, and we're going to get water at the end as well. Okay, so starting off with our carbons, we've got 4 carbons here, so we're going to put a 4 out the front of this carbon over here. Okay, so now we've balanced up our carbons, we're going to leave our oxygens to the end. So the next thing we're going to do is our hydrogens. We've got 10 hydrogens here, so we're going to balance up with a 5 out the front of the water over here, because that 5 times by the 2 hydrogens that we've got here in H2O will give us our 10 hydrogens. So the last thing we're now going to do is look at the oxygens. Over this side we've got 4 times 2, so we've got 8 oxygens here, and we've got another 5 here, all right, which all total gives us 13 oxygens. Now, 13 and 2 are not nice numbers to try and work together. So as I said, you can try and double everything, go around that way if you want, but there's a much simpler way to do this, all right? We want 13 oxygens, okay? So over here you just put a 13, okay? I'll try and make this a little bit clearer, sorry. You put a 13 there, and then you just put it over 2. because 13 over 2 times by 2, those will cancel out, and you'll just be left with your 13 oxygens that you want. So balancing using fractions out the front of your oxygen is much simpler in combustion reactions and saves you a lot of time, so I suggest you do that. What I'm going to show you now is an incomplete combustion reaction. Three, two, one. And so the incomplete combustion reaction I'm going to show you will just be one of propane, C3H8. Okay, sorry, my blue pen's running out. I won't use it again in the next video. And we're going to react that with oxygen. Okay, and this time I'm just going to go down because otherwise I'll run out of space there and you won't be able to see it properly. So I'm going to run down and we're going to get our incomplete combustion products here, which are carbon dioxide, water vapor, carbon monoxide, and carbon. So we're going to get CO2, we're going to get H2O, just like we did before, okay? But we're also going to get carbon monoxide, and we're going to get carbon as well. Now for incomplete combustion reactions, you kind of go a little bit differently from your carbon, hydrogen, and oxygen, which I told you to do last time. What I do is I now do hydrogens first, then oxygens, and then carbons at the end, okay? So we've got 8 hydrogens here, okay? So we're going to have a 4 in front of the water. And that's why I start with the hydrogens for an incomplete combustion reaction, because they're still only in one spot. Then I have a look at my oxygens over here. Well, it's up to you really if you want to do hydrogen, if you want to do oxygen or carbon. You can see here that we've got 3 carbons up here and we've got 1, 2, 3 carbons here. So they're actually already balanced, so this one's a little bit easier, okay? But it's up to you which way you want to do it in this one. But we're going to have a look here. We've got 2 oxygens, so 2 oxygens here, another 4 oxygens here, okay, because there's a 4 out the front. So that gives us 4 lots of oxygens here off the water. Okay, we've got another 1 oxygen there. So that gives us 2, 4, and that gives us 8, if I can add up correctly. 2 plus 4 is 6, plus 1 is 7. So we've got 7 oxygens. So again, you can just use fractions to balance up if you want. 7 over 2, and that will balance up this equation for you nicely. Okay, you can, if you want, add in extra carbons if you want as well to get a whole number for oxygen. Doesn't really matter, okay? Combustion reactions, the whole point is that you've got less oxygen than you do in a normal combustion reaction for an incomplete combustion reaction like this, okay? Hopefully this has been fairly straightforward. What I suggest you do is just find a couple of organic molecules, all right? I'll give you a couple here. So try doing one for octane, C8H18, just here, okay? Try doing an equation for the complete combustion of that and the incomplete combustion of that. I'll put the answers for that at the end of this video. All right, hope this has been helpful. As always, best way to remember this is just that complete combustion is CO2 and H2O as your products. Incomplete combustion, less energy released, you get carbon monoxide and carbon as your products. If you've got any questions, just ask and feel free to leave a like. Thanks, guys.